Okay, let's take a look at a scenario like this. So we've got our table where we have x on one side and the corresponding g of x values on the other side, right? If we just look at the values of g of x, it's growing way too fast to be a linear function, right? It's got to be an exponential function. So it's got to be in the form g of x, and I'm going to use a slightly different notation this time. It's going to be g of x, g of x equals a times r to the x power, r for ratio. This is the exact same thing, right, as if we used a times b of x, right? We're just using a different variable to stand for the common ratio. So today I just want to use this letter r to stand for the common ratio, just because why not? Okay, so we got to find a, our initial value, and we've got to find r, our ratio. Oh boy, it looks like we're in trouble this time, right? We aren't given what the value of g of 0 is, right? We know that g of 0 is what a equals the initial value, right? Our last couple times we've worked with problems like that, we were always given the value 0 among our x's in our table, right? So we were able to just go ahead and look at what the g of x value corresponding to x equals 0 was. And immediately at that point, we were able to find our a value, right? Well, we can't do that this time. What else can't we do? Can we find r? Can we find our common ratio? Well, if we have g of 4, right? We have g of 4. So we'd like to have g of 3, wouldn't we? We'd like to have our immediately previous value in order to find r, right? Okay, we're in something of a pickle this time, aren't we? So let's think about what we can do. Let's think about what we can do. Luckily, we know enough about exponential functions to be able to solve this. All right, we know enough at this point. So let's think. Let's think of what an exponential function is, right? Well, you start with your common value. Sorry, you start with your initial value and you multiply by the same thing each time, right? Like for example, we know that g of 2, to get to g of 2, right, we would have had to start at our initial value, g of 0, right, or a, and we would have had to multiply by r once to get to g of 1, and then we would have had to multiply by r again to get to g of 2, right? We know to get to g of 4, right? To get to g of 4, right? We would have had to start at our initial value, a, g of 0, and then multiply by r how many times? 4 times, right? Okay, so let's use our basic understanding of how and why exponential functions work and see if we can figure out this information. Okay, let's make a new table. Let's make a new table with x and with g of x, okay? Let's start at 0. Go from 1, 2, 3, 4, 5, 6. Why not, okay? All right, let's do that. Let's do this and let's set up our table, okay? We're going to set up our table here. All right, let's fill in what we know. We know g of 2 is 144. Okay, we know g of 4 is 576. We know g of 6 is 2,304, right? Okay, so whatever g of 0 was, right? Whatever this initial value a was, right? We know that we would have had to multiply by our common ratio r to get to g of 1, right? And we know we would have had to multiply by our common ratio r again to get to g of 2, right? Okay, so let me make some room here and see what we can do. Let me make some room and see what we can do. Okay, so we know for a fact that if we started with a, right? Let me get my brush back. If we started with a and multiplied by r once, we would get to g of 1. And if we multiplied by r again, we would get to g of 2, right? So we know that g of 2, we also know this to be the case, that g of 2 equals a times r squared, right? So let's try to put this fact here aside in our mind for a minute, okay? And now let's go on. Now that we're at g of 2, we know g of 2 equals 144. So we know that 144 times r, again, would get us to g of 3. And we know that g of 3 times r, again, would get us to 576, right? So what do we know? We know that 144 times r, right, would get us to our next term, g of 3, right? Let me write that one. Wish I had more room. 144 times r, right? And we know that 144 times r again, right, would get us to 576, right? Okay, so let me get rid of this big table here, since that's information we already have. And let's look at this. Whoops, let's look at this, okay? Okay, so we know that 144 times r squared equals 576, don't we? We should know that, right? Because if g of 2, right, if g of 2 equals 144, then 144 times the common ratio gets us to g of 3, and then from there on, if we multiply by the common ratio again, that gets us to g of 4, right? So 144 times r twice, or times r squared, is going to equal g of 4, 576. I know that this is a lot of numbers and information and operations to keep track of, but put in some effort. I know it might take a while for this to saturate your brain, but it will. It will if you keep paying attention and keep putting in an effort. Okay. So now we're at this point, what can we do? Well, let's work to solve for r. Okay. Let's go ahead and divide both sides by 144, right? If we divide both sides by 144, we're going to get r squared by itself, right? So therefore, r squared is equal to what? Well, 576 divided by 144 is 4. Okay, this helps, doesn't it? If r squared is 4, that means r is the square root of 4, which is 2. See? Because if r squared is 4, r has to be 2, right? And this should make sense now, right? So let me get my eraser. Now that we know what our common ratio is, right? Now that we know what our common ratio is, we should be able to fill out all kinds of information, right? So let's keep at 144. We know to get to the next term, we have to multiply by our common ratio, which now we know is 2, right? So our next term should be 288, right? To get to g of 4, we should multiply by r again. We will indeed get 576. To get to our fifth term, we should multiply by r again, which in this case will be 576 times 2, 1,152. Okay, so now how do we figure out what g of 0 and even what g of 1 is, okay? Well, let's figure out g of 1 first of all. Sorry, let's figure out g of 0, which is a, first of all. Let's figure that out first. Okay, let's figure that out first. Let's get rid of this. Let me bring my writing tool back up. Okay, so we know that if we start at a, right? If we start at a, multiply by r once, right? That's g of 1, right? And if we start at a and multiply by r twice, that's g of 2, right? Okay, so we know that a times r squared is g of 2, right? We already knew that back here. So now that we know that a times the ratio squared is g of 2, let me make some more space and write out the fact that, that a times 2 squared, since we know that r is equal to 2, right? A times 2 squared is now equal to 144, right? Okay, what does that mean? That means a times 4, right, is equal to 144, because we know what 2 squared is. And can we divide 4 by both sides? Divide both sides by 4? get a by itself? We can, and we'll figure out that a is equal to 36. A is equal to 36, right? All right, so we've got a equal to 36. Let me write that here. A is equal to 36. And finally, can we fill in our last missing piece? What is g of 1? Well, we're just going to start at g of 0, our initial value, multiply by the common ratio once, and get 72, because 36 times 2 is 72, right? So we've been able to fill out our entire table by figuring out how to fill out the entire table, right? We figured out the two things we need to know. We figured out that a is equal to 36. We figured out that r is equal to positive 2. So g of x is equal to 36 times 2 to the x power. And we were able to figure out all of that by just knowing, remember what we were told in the beginning. In the beginning, we were only told that we only had these 3 data points, right? And from these 3 data points, with our knowledge of exponential functions, we were able to figure out all the rest of this information.